All right, we're going to go ahead and go through here and look at some other kinds of surfaces other than just planes. So let's get going with this. First we have is the general idea of a cylinder, and it's a surface that is generated by moving a straight line along a given planar curve while holding a line parallel to a given fixed line. The curve is called a generating curve for the cylinder. So if we look at this one here, this would be our generating curve right here, this red line, like we were looking at a piece of paper, okay? And then we would have a line that we would want to move along and stay parallel with. In this case, the line we could look at would be something like the x-axis here is what they're using. So let's say we have this x-axis here. And then what we're going to do is take, and you can see all the blue lines. The blue lines are all parallel to the x-axis, and they're all moving along this red line that's our generating curve. So when you do that, you're taking like this line and you're just kind of moving it along in this direction and keeping it parallel to that green line. And we're generating what is called a cylinder. The reason you can think of this as a cylinder is because if I take these two ends and I roll them together, I have a cylinder, right? If I take the two ends of a sheet of paper and you roll them around together, right, like that, you get a cylinder. So you can roll this up into a cylinder, this kind of a surface. That's why it's called that. It's mathematically the same. You're not going to do anything different. In fact, if you take a cylinder and you cut it like that, you roll it out and it's a flat sheet of paper like that, and it would fit these properties. So the cylinder, the generating curve for the actual cylinder you're used to would be like a circle, and then you would take a line that was perpendicular to the edge of that circle, like say, this line here, and then just do all these lines keeping it parallel as you moved along and around that generating curve out here. Okay, so here's an example. Find an equation for the cylinder made by the lines parallel to the z-axis. So all the lines parallel to the z-axis that pass through the parabola. So the parabola here, this parabola is our generating curve. And then what we're going to do is take all the points that are parallel to the z-axis and cross through that generating curve. So it's going to be this line, and then this line, and then this line, and this line. And technically they keep going up. We're not stopping right there. But we would just keep going around, all the way around this, filling in all these lines, and we would end up making the shape we want. The way you can look at this is it's essentially y equals x squared, right? And it's that case when z equals 0. That's the y equals x squared is our generating curve when z equals 0, and we've got everything from there. So next, a quadratic surface. Now doing these, they're going to be of this kind of a form here. What you're going to want to be careful of is making sure that you know what equations for ellipses look like. And circles are just special cases of ellipses. So this is like ax squared plus bx, or not ax, not bx, by squared equals some number c, right? You're going to want to know parabolas. This is like ax squared equals y kind of a thing. You're going to want to know hyperbolics, and that's going to be something like ax squared minus by squared. So you want to know these old kind of graphing things, and so we can go through and kind of figure these things out, and I'll show you what I mean by this soon. So take a look here. First one, this is in ellipsoid. This is basically ellipses in all different directions. So if we look at the overall equation of this here, this equation right here, basically, for example, if you look up here at this picture, if we look at the picture and we make x equal to 0, right, you can see this is the outer edge at x equals 0. In other words, where does this ellipsoid, this egg-shaped thing, where does it cross the yz plane? And here I'll draw it on this one too. It's going to be this circle, or this ellipse right there, which means if x equals 0, that goes to 0, right? We have the equation left for an ellipse, right? That was this thing right here, okay? Except, you know, in my case, my a and b would have been like 1 over a squared or something like that. Okay, but you get the general idea. You have two different coefficients in front of your two variables being added together, and then they are equaling some constant. Okay, and if we don't make x 0, but we make it some other constant, like say 3, then we're coming out here further on the surface, and we're still taking that cross section out here at x equals 3, and we're still getting a cross-section that is still an ellipse. It's just a different ellipse. And so anywhere we go setting x equal to 0, you know, if we look at it straight down the x side, we're getting ellipses. And then the same thing happens for y. If we project this onto, right, let me get rid of that. If we project this onto the xz plane, that makes the y, making y equal to 0. That gives us this ellipse right here, which we can see is right here as well. It's also an ellipse, and that would be setting this equal to 0. And then again, you have an ellipse equation. You don't necessarily have to set it equal to 0. You can set it equal to another constant. Like again, if you set it equal to 3, it would come down and make an ellipse over here, like that. All the cross sections would be ellipses. And then the same thing for z. You can do the same thing, go through the z-axis, right? Making things, if you want it in the xy plane, you make z equal to 0 this time. That goes away, and you have ellipses in this direction. And if you make z just equal to some other constant, like 3 or something, you get ellipses going up that way. And again, remember, circles are just special cases of ellipses. Make z equal to some negative, you get an ellipse down there. So it's just ellipsoids. Every cross section you make of this is an ellipse. And so every one of these variables, if you take and make one of them a constant or make one of them 0, you end up with the equation for an ellipse. So it's an ellipse in all directions. This one has hyperbola and parabolas. So if we look at our actual equation here, right? Y squared over b squared minus x squared over a squared equals z over c. If we look at this, so let's take first and let's project z into 0. So we're going to project this down into the xy plane and just look where it crosses the xy plane. Well, if we look at where it crosses the xy plane, that goes to 0. This is the equation of a hyperbola. All right, and you can see what would happen is we would have this sort of shape going on there and this sort of shape going on over here, and that would be in that plane for the xy plane when z is equal to 0. Okay, and then you can see they also even drew some up here where you just generally make z a constant, not necessarily 0. 0 is the easiest one, but you make it some other constant, and it's just parabolas all the way up, and parabolas would be all down here as well. Not parabolas, hyperbolae. Hyperbolas would be all down here. They'd be everywhere. All right. The other thing that we could do is take one of these and make them 0. And if we make like x 0, then we're in the yz plane, and you have y squared, right? You have a y squared is proportional to a z. That's a parabola, okay? You have a y squared and then just a regular term, like y'all are used to y equals x squared. That's a parabola. Or y equals ax squared or something like that. So what we can do is take y squared over b squared equals z over c, right? And just multiply both sides by c. And you have c over b squared, that's some number, times y squared equals z, which is just a y squared equals z, right? And that's, I know I got those a little jammed together there, but that's the equation for a parabola right there. And so it has to be parabolic in the yz plane. All right, and if you look, they have a blue one drawn here. You see it's a positive parabola pointing upward around the z-axis, just like y equals ax squared would be a parabola like that, where this is the x-axis, this is the y-axis. Okay, but now look at what happens if we take this time and we set y equal to 0, right? If we set y equal to 0 or to some constant, what happens is we have negative x squared over a squared equals 0. See, that's it like this form, where we have a negative ax squared. That would be a parabola facing downward around the y-axis. In this case, we're looking at the zx axis, and this has to be a negative parabola, a downward, flipped upside down parabola that's going around the z-axis. And that's what you have right there in that green one. It would be parabolas. And anywhere you'd move along here, you'd have some sort of downward facing parabola. And you can see that right there even in the very edges of this. It's a downward facing parabola. So you can change the values of y to being different positive or negative constants, and everywhere you take that cross section, you have a parabola. And so overall, it gives you this saddle looking shape here, and that's what you have, okay? So just make sure you're familiar with all these. Here's the ellipsoid again. I already talked about this one in the last page. Here, an elliptical paraboloid. So obviously, ellipses and parabolas, okay? That's what we're seeing in this. And you can see that if we set z equal to a constant, z equals to some number, we have x squared plus y squared just equals some number, some constant. That's the equation for an ellipse. And that's what you get when you are parallel to the xy plane. You get ellipses. Every cross section you take is an ellipse like that. Okay? If you take and we make x equal to 0 or some constant, if x is 0, you get parabolas. There's a parabola, there'd be a parabola over here, little parabolas over here. Everywhere it would be parabolas on these cross sections where you were in when you were looking, I made x equal to 0. I'm sorry, when I make x equal to 0, we get that in the yz plane. We get these parabolas. So then, although I think I drew on the blue one, we get parabolas like this and parabolas out here. That's hard to draw on these three-dimensional pictures, but you get parabolas. And the same thing here, if we make y equal to 0, then we're going to get parabolas that are in the xz plane, or make y equal to some constant, and you get parabolas, in whatever plane that happens to be. Okay, so you have ellipses and parabolas. Here we have ellipses and a cone. All right, if you look at this one, if we start with making z equal to some number, just some number, we have an equation for ellipse again. So ellipse, ellipse, ellipses, ellipses everywhere. All right, when z is just some constant. If we make y equal to some 0 number, if we're looking in the xz plane or planes parallel to xz, we have x squared equals z squared, right? And that's just going to give us, when we take the square root, ignoring the constants, it just gives us x over a equals z over c, right? Which gives us that gives us some constant number, 1 over, or c over a, times x equals z. That's just a straight line. That's a linear equation, and that's what we have here. We have straight lines in the xz plane. And then you can do the same thing for setting x equal to 0, and you'll get a straight lines again from just this part. You'll have y times some constant equals z, which is your slope, mx, and then if this is some constant number non-zero, then you have a y equals mx plus b. This would be the number, you'd have some mx or my here equals z. And it's a straight line in that. It's that linear equation or form, and that's what you get. So you're basically going to want to do these by taking each part and setting them equal to 0 or to constants to see what shape it takes in that direction, and then kind of three-dimensionally building it out. This is a hyperboloid. Hyperboloid, I guess. I don't know. I'm not saying that very well at all. It's a hyperboloid of one sheet. You can make fun of me for that later. But look what we have here. If we go to the z equals a constant, so this is just some number here, or even 0, we get ellipses in this direction, all right? If we go in another direction where we make, like, say, y, we get rid of y, and we just look at the xz plane, what you see are hyperbolas. Hyperbolas, right there and right there. You have a hyperbola. And if you do the same thing for x, you make the x equals 0, you get these hyperbolas over here. And so that's what you get. Now this is of one sheet. This will make more sense, the of one sheet addition on there, when we look at the next one. Because the next one, you notice, here we have a hyperboloid of 2 sheets. So look at the difference here. Pretty much same equation, right? Except this time we have x and y's as negatives instead of the z as the negative, right? In other words, it's the same exact equation if we just put a negative in front of the 1, okay? So if I take that same one, all right, this is x squared over a squared plus y squared over b squared minus z squared over c squared, and I set it equal to -1. That's the equation from the previous page, but make it a -1 right there, then it immediately becomes that version right there, in which case we get a hyperboloid of 2 sheets. And what you see is, again, if we go in the xy plane, when we get rid of that z, we get ellipses again. It's just ellipses everywhere. Ellipses, 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 ellipses. But if we go and set these others up, we end up with negative hyperbolas, but we still end up with hyperbolas. It's just now the hyperbolas in the xz plane, we have hyperbolas there. And in the yz plane, we have hyperbolas there. It's just now we have this big split and gap right there. Okay, hence the 2 sheets. Okay, 2 sheets. But otherwise, very similar to the previous one. And again, notice, we have hyperbolas there. And so that's what the name we get. Here, hyperbolic paraboloid. You're looking at something with hyperbolas and parabolas. And you can see it right there. You've got parabolas going this way. We looked at this one already. We've got parabolas going that way, and we've got hyperbolas going this way. So that's what you get. You can see them, the hyperbolas there in pink, the parabolas in blue and green in the different directions. Okay, and we talked about that one already. And I think that was it. I think I just added an extra page. So, yep, that's it for this section. So what you're going to want to be able to do with this is you're going to want to be given an equation, and you're going to want to be able to go through and figure out what it looks like. So let's say, for example, we were looking at something like x equals y squared minus z squared. If we're looking at that, what we can do is look at this and say, all right, well, what's the first thing that happens? We've got our x, y, and our z coordinate system here. So we'll do it like this. X, Y, Z, just like that. All right, sorry about that little jump there. I got interrupted here. So how do we do this is we're going to start by just, or at least the way I like to do it, is to make each one of these 0. So let's start with making y equal to 0. So I'll do that in y equals 0, we'll do in purple. If y equals 0, we have x equals -z squared. That's going to be a negative parabola in the xz plane. So this is x, this is z. So we rotated this so that the y-axis is pointing out toward us. This is x, this is z, right? We have to have a parabola that faces backwards this way in that plane. So if I try to draw that in, it's going to look something, oops, that wasn't very good. It's going to look something like, that's still not very good. undo that line. It's gonna do something like that, going kind of back at an angle in the XZ plane. And then if I then try to do Z equals 0, I end up in the XY plane, because Z is equal to 0, and that one I'll do in, let's say, blue. So in the XY plane, I guess I'm going to rotate this such that X is pointing like straight down, and this is for Z equals 0, and then this is Y and this is X, right? So I just rotated it down a little bit. Then I end up with a positive parabola around the x-axis like that. And so if I try to draw that in, it's going to look like this, right? And so then the last one is to do when x equals 0. If x equals 0, I get y. Y equals, or y squared equals z squared, which is just y equals z, which means in the YZ plane, right? In the YZ plane, I'm going to have some sort of straight lines. And so ultimately, oh no, I'm sorry. I have y minus z equals some constant when x is non-zero. We can't make x equal 0. We have to make x equal to a constant. Okay? And then in that point, because, well, in the xy plane, I would have, if it was equal to 0, I would have these crossing straight lines like this. But what I have, because I have to have plus or minus, because it's y equals plus or minus z, right? I'd have these crossing straight lines. But if I move off of it to where it's a constant value, what I actually start ending up with is hyperbolas. Hyperbolas going this way like that. And so I don't know if I can actually draw this, but I'm going to try sketching it real quick. So if we have x, y, and z like this, what you'll end up with is a graph where it kind of looks like this on this side, and it's going like this over here on this side, and then it's like curving in this way over here, and you have this kind of a sheet that's going around, and it's curving over that way over there like this. And so you're getting these parabolas, right? If I try this real quick in purple, you're getting these parabolas in this direction, right? Like I drew there, going back. And then you're getting, what was the next color I did? Blue. You're getting these parabolas going this way on it, on the surface. So I didn't draw that there. So it's like a parabola up here and parabolas down there as you move up or down in the z direction. And then in the x, when we make x the one we're zeroing out, along there we would have straight lines like this, but as we move further out and took cross sections, we'd get these two separate hyperbolic cross sections like that as we went through. So anyway, hard to kind of draw, but hopefully that makes some sense to you. This is the sort of thing you're going to be doing for this kind of homework. You're going to want to take these and identify what shapes you have in each direction and come up with an overall solution, okay, or an overall what the three-dimensional graph will look like. So it takes some practice, it takes some getting used to, but best thing to do here is just practice until you learn to do it the way I'm showing you, where you zero stuff out and see what shapes are in the different planes, and rebuild it, or start memorizing. Memorize them all is really the best advice I can give if you're having trouble with this. All right, so that's pretty much it. Thanks for listening. Bye.